All right, so let's go over the test. Okay, the first three, I think some of you guys, I don't remember who, I just made some, I think you can figure this out, right? They're just, the first one is just like simple power rule, but you gotta be careful with negatives and stuff. The second one is a u substitution. If you let u equal x squared, du x cubed, du is 3x squared dx, gets rid of all the other stuff, and you just have sine of u. So it's negative cosine of u, which is x cubed. So it's negative cosine of x cubed plus c. That was a lot to go over, but I can show you my answer key. And then the third one, x over 4 minus x squared. So again, they're all u substitutions. So x over 4 minus x squared dx. So you let u equal 4 minus x squared. Du is negative 2x dx. We have an x in the dx. So the x dx is negative du over 2. So we replace x dx with negative du over 2. So you have an integral of negative 1/2 1 over u du, which is just natural log of u, negative 1/2 natural log, absolute value of u, but just plug that. So negative 1/2 ln of 4 minus x squared plus c. So again, just a u substitution. And the next one is just a u substitution. This one, number 4, you had to get an actual answer. And again, you can leave it as the perfect answer. So number 4, no. You have this down on? Yeah. Okay. So number 4 is similar. We got all this cosine sine stuff, which looks complicated, but it works out really well because it's just 0 pi over 2 cosine x over 3 minus 2 sine x dx. So we just let u equal the bottom. U equals 3 minus 2 sine x du. That goes away. Derivative of sine is cosine, so negative 2 cosine x dx. We have a cosine x dx. We don't have the negative 2. So this just becomes negative 1/2 again. There's that 2 integral from 0 to pi over 2. The u takes out the cosine x dx, goes away. Right, cosine x dx is equal to negative du over 2. That's that. So we just have 1 over u again. Now we could change the limits right away, or we can just plug in the x. Either one works. So this is just negative 1/2 ln of u, ln of that, 3 minus 2 sine x, from 0 to pi over 2. Plug in 0, plug in pi over 2, and I got, it's just, yeah, because ln of, plug in pi over 2, this is 0. Sine of pi, wait, no, sine of pi over 2 is 1. So that's ln of 1, which is 0. Plug in 0, this is 0, so it's just ln of 3, and it's minus. So you end up getting just 1/2 ln of 3. And you don't need absolute values if it's positive. Right, we put the absolute values there just in case you get negative, but it ends up being just ln of 3. So it's 1/2 the natural log of 3. Again, I skipped some steps, but again, you plug in pi over 2, it's 3 minus 2. ln of 1 is 0. So it's 0 minus ln of 3. So you just have to be brave, do the use substitution, and go for it, right? And be really careful with algebra. Okay. Let's look at the next one, the fundamental theorem of calculus one, which, okay, I guess people didn't recognize that it was a fundamental theorem of calculus one. You can actually integrate it. You can integrate it and plug in the numbers and then take the derivative. That works because I made it something you can integrate. But I could have put something there you can't integrate because you're not supposed to integrate it. The derivative cancels out the integral. So we want g prime of 2. We want the derivative. So in this case, again, you can take the integral and then take the derivative when you're done. But no one did that correctly, I don't think. Because yeah, but you can do that. So, well, we could do it both ways. But so we want g prime of 2. So g of x, we want the derivative of the integral, right? Which cancels out the integral. So that's 3 to 2x cubed sine 5 sine of x dx. So all you gotta do, right, is you remember the 3 doesn't matter. You plug this into here to take g prime. So g prime of x. Take the derivative, gets rid of the integral. You plug that in, so it's 5 sine of 2x cubed. But then you say, oh wait, that's a 2x cubed. We got to use the chain rule. So multiplied by 6x squared. So that's what g prime of x is. Gets rid of the integral. You just plug that in. Use the chain rule. Now, g prime of 2, you just stick a 2 in, is 5 sine, let's see, that's 16. 16, that's 6 times 4, 4 times 24, so it'd be 120 sine of 16. I said just to leave it as sine of 16. You could get a number for it, but that's the perfect answer. So the whole point is, again, using the fundamental theorem of calculus, derivatives cancel out integrals. Derivatives are the same thing as an integral. Since this is a 3, okay, and here's where people messed up. When you plug in 3, if you were to actually do the integral, you plug in 3. When you take the derivative of a constant is 0. So you shouldn't have that part. That goes away. That's why the 3 doesn't matter. Because you plug in 3, you get an actual number. And the derivative of a number is 0. Here we plug in an x. The derivative of an x is something. So again, you could do it, just take the integral and then take the derivative of it. But then you get rid of the constant part. The 3 doesn't matter. I think that's, Callan, you did that, but you left the 3 in there or something. But if you did that, the derivative of it's 0. But the easy way to do it, again, is just, you're supposed to just use, ideally, I put something here you can't integrate. So you can't do it that way. You just use, oh, fundamental theorem of calculus. Derivative of the integral, you don't have to integrate. You just plug this into here, use a chain rule, and then plug in 2. Okay, number 6, everybody got A and B right, and no one got C right. I don't know, or I got it wrong, so we'll do it again and make sure that maybe I got it wrong, but no one, I was hoping everybody had the same answer, I wouldn't have to do anything. But everyone had different answers, and none of them were the same answer that I got, so let's look at that one. So the velocity was negative 4t squared plus 4. Everybody got that right. I think everybody got that 6b. How high was it? T equals 0. It's 24. And then with the total distance traveled. So the total distance traveled is the integral of the velocity versus time dt. But absolute value, we always want to make whatever in there is positive. So we have to make sure it's positive. And the way you get rid of absolute values is you find where it's negative and you make it positive, right? So, and I think some people put the distance in there. It's, you integrate the velocity. So, okay, so we got to figure out where is that positive, where it's negative, and where it's negative, we make it positive. So between 0 and 3 seconds, so 0 to 3 seconds. So let's see, the velocity we already figured out was negative 4t squared plus 4. We want to figure out when is that 0, and then when is it negative, when is it positive. So when is that 0? So it's 4 equals 4t squared, 1 equals t squared, or t equals plus or minus 1. We don't care about the negative one. We want 0 to 3 seconds. So negative 1 switches over from, sorry, positive 1 switches over from positive negative or negative positive. So we plug it in. If we plug in 1, or plug in 0, it's t equals 0. Wait. Oh yeah, t equals 0, the velocity is 4. So it's positive first. So it's positive between 0 and 1 seconds, it's positive. And between 1 and 3 seconds, it's negative. Plug in like 3, and this one wins, right? 9, so the negative wins. So it's positive between 0 and 1 and negative 1 and 3. So this becomes the integral from 0 to 1 of just negative 4t squared plus 4 dt minus the integral from 1 to 3 of negative 4t squared plus 4 dt. Because this is going to be negative, so we subtract it to make it positive. Each one of these should give us a positive answer. The integrals are easy, it's just a lot of numbers. So the integral is easy, the same integral both times, right? So t cubed over 3. So negative 4 t cubed over 3 plus 4t from 0 to 1 minus negative 4 t cubed over 3, which makes it a plus 4 t cubed over 3 plus 4t minus 4. Okay, you gotta be careful here. I'll just do this. Minus negative 4t cubed over 3 minus 4t from 1 to 3. T cubed over 3 minus plus 4t. I'll put the minus there. You gotta be really careful with these minuses. So it's minus, and then I'll just do the splits inside here. Negative 4t cubed over 3 plus 4t. Do all this stuff. Okay, it's a lot of work. You work through all that, you don't make a mistake. I got that it's 29 1/3. So you plug all those things in, you plug in 0, you plug in 1. Obviously 0, let's just do it to make sure I did it right. So if you plug in 1, you get t is 1, that's just negative 4/3. Negative 4/3 plus 4. Plug in 0, you get 0, that's easy. Negative 4/3, yep, t equals 1. Okay, then minus, plug in 3, t cubed is 27, divided by 3 is 9. Takes away the s, so that's just 9 times negative 4, negative 36. So negative 36 plus, plug in 3, 12, minus what you get when you plug in 1. So you plug in 1, you get that over there. You get negative 4/3 plus 4. So you got to be really, really careful, right? So I kept the minus, negative, plug in 3, minus what you get when you plug in 1. Oh my gosh. Okay, let's write out all this stuff here. So I get negative 4/3 plus 4 from here minus negative 36, so plus 36, minus 12, minus 12, minus negative is plus, minus, so minus 4/3. Right, those two cancel, but we have a minus there. Minus 4, but that makes it a plus, so plus 4. And any luck, I did it right. Okay, so we have 4 plus 4 is 8, plus 36 is 44, minus 12 is 32. So 32 minus 8/3. So that's 2 2/3. So yeah, so 29 1/3. Yep, so I did it right. You gotta be super careful with all that stuff. So the total distance it went was 29 1/3. I think, Callan, you did it right, but somewhere in the algebra, I don't know, I couldn't figure out where you went wrong. Good. And Juan, I think you did it hard, like you integrated the distance or something.
Yeah,
You integrated it twice.
Velocity.
Yeah, so then it's like way harder for one. So you made it way harder on yourself, and of course it's wrong besides that, but it's also much harder because you got even more t's going on.
Yeah.
So, but you integrate velocity to get distance, right? The distance is the area underneath the velocity or the sign. Velocity times time is distance.
I just didn't do the second integral.
Oh, is that what it was?
As to the absolute value of all.
So yeah, so the way you deal with absolute values, I always say, is you get rid of them. Where it's negative, you make it negative. To make it positive, or it's positive, you don't have to worry about it. Okay, does it make sense? It's just, again, a lot of work. Okay, hey, I wonder if Buster showed up yet. Buster, he's off skiing. All right, so then what are we at to here now? The last page. We have these crazy integrals. Okay, so now we have the volume ones. And okay, so the first one, I showed you the graph there. I copied this from like an old test. So, because they have the graph there nicely and everything. So we want to do the volume by rotating r bar. Okay, so here's the trick. We have this graph. Draw the graph up here. Looks like this. So we want this area. And this is 3 here. So we want to do that around the y equal -2, which is down here. This is -2. Okay, so you don't want to do cylindrical shells because we have 2 places that we have to, if you do cylindrical shells, you draw a shell. Here is to the line. And then from this point, we have it, it's like this. So if you do, you got to break up into 2 parts, cylindrical shells from here to here, and then another cylindrical shells from here to here. Well, what you can do, you can break it up into 2 parts, but that's way too much work. So instead, what you do is you use washers, which is way easier. Now, again, you can do cylindrical shells, but washers is way easier because if you do that, you got to break it in 2 parts. So you do washers here. So then we just know that the volume is the integral, let's see, of pi x squared, pi radius squared. So pi times the big radius squared, which is this, plus 2. That's going to be -2, so plus 2. And that is the function. And the function is y is equal to square root of x plus 1. So it's square root of x plus 1 plus 2 squared. That's the outside one, minus pi times the inside radius, which is just 2. So pi times 2 squared dx. Because right, this is a dx because it's a washer, so there's a width there, so it's a dx. And again, you can solve this. We could have done this, but it'd just be a huge amount of work, and it's not hard. So it's like setting it up is the hard part. Doing the integral will just take a lot of time and doesn't really help you do anything. Okay, so that was part A. I think, Cal, you got that right. I think, yeah. Then part B, find the volume obtained by rate around the x-axis. So the x-axis, we go this way. So again, we can't do washers or discs because from here to here, it's a different thing, right? Here we have a disc, but then if we do this one, it's like from the curve to here, and here it's from here to here. So if you do, you have to break it up into 2 parts. You can do it, but you got to figure out that point, which I think is 1, so it's not so bad. But you'd have to do it twice, from here to here, and then from here to here. So it's better to use the green one again, and do cylindrical shells around the x. Wait, around the x-axis. Sorry, I was thinking around the y-axis. That was a big part, which a lot of other people did too. Switch it around. A lot of other people went through in the class, but switch it around. Yeah, I think who's first? I think
Yes,
yeah. I was just doing the same thing. About the x-axis. X-axis is this way. So we can use washers again. We can use washers. We can use this green one here. Not washers, there's no hole. So I should say discs or something. There's no hole around the x-axis. So like that. It's always the top of the curve here. So the radius is y. The radius is y. So it's just x goes from 0 to 3. Oh, I forgot to say where it goes from here. X, it's dx, so yeah, it just goes from 0 to 3. It's dx, the x goes from 0 to 3. Here it's dx2, so 0 to 3. Pi, just the height squared. So square root of x plus 1 squared dx. Real easy integral because that's just x plus 1. Plug in everything right. Go from 0 to 3, and I got 15 pi over 2. So that one's 15 pi over 2. The next one is the y-axis. Y-axis, you have to do cylindrical shells so that, because it's again, you use the green one. Right? You use the green one, and you sweep it around. That way, the height is always the y function. Otherwise, like I said before, you'd have to do 2 different things. With discs, you'd have to do one from here to here, and then a separate one from here to here, which again, you can do, but it's easier to use cylindrical shells. So that one becomes, it's an x, it's dx, and so our box looks like this. It's dx, we're integrating with x. The height is y. So the height is y, which is square root of x plus 1. And the radius is just 2 pi x. Because the x is just the radius. So it's 2 pi x times the square root of x plus 1 times dx. So that's the integral. To do this, you got to get rid of, to integrate that, you have to use a u substitution. So this is the integral, but we can get an answer. It ends up being a lot of fractions. Holy, it was actually a lot of fractional work. But to do this, what you do is you let u equal x plus 1, du equals dx. And then to get rid of that x is equal to u minus 1. So this integral becomes integral from 0 to 3, 2 pi x is u minus 1 times the square root of u du. And it's really not 0 to 3. So I changed my limits here so I don't have to go back to x's. I said that when x equals 0, u is equal to 0 plus 1, u is equal to 1. when x equals 3, u is equal to x plus 1 is 4. So 4. So really, we never have to go back to x's if we change our u as 1 to 4. 0 becomes 1. 3 becomes 4. I'll do one more step here. So that's the integral from 1 to 4. We'll pick the 2 pi out in the front. Get rid of the 2 pi, put out in the front. Square root of u times u is u to the 3/2. Square root of u times minus 1 is minus u to the 1/2 du. It's about 4. Now it's a whole lot of algebra. Lots and lots of fractions and plugging in. You know, because u to the 3/2, you integrate that, you get u to the 5/2 divided by 5/2. U to the 1/2, you get u to the 3/2 divided by 3/2, multiplied by the 2 pi. A whole lot of algebra. Took me like I had to start writing small and keep my fractions and everything. And then eventually I got 232 pi over 15. 232 pi over 15 is what I finally got up to do. Really, really careful with the algebra and everything. Did anyone get that right? I think someone did.
I switched it, but I got it right.
Okay, you did the top one, bottom one, I think. Okay, yeah, Buster got the 15 pi over 2, but then he got 46 pi over 15. So he obviously did something right, but again, there's a lot of algebra. These u to the 3/2, again, u to the 5/2 over 5/2. You got to be super careful with all the fractions. Yeah. Okay. So
Can you just go over how you got u to the 3/2?
u square root of u times u. So if you got to show all your work really well, so if you have a u is u to the 1 times u to the 1/2. And when you multiply common bases, you add, right? So that's equal to u to the 1 plus 1/2, which is u to the 3/2. So if you multiply u's, you add the exponents. U to the -1, of course, that's the square root of u, which is u to the 1/2. But u times square root of u times u is u to the 3/2. So yeah, you gotta be really careful with all that stuff too. So that was tricky. You had to do all this with the u substitution, solve for x. But you know, we've done ones like that before. I think part of the problem was it had been a while since we'd done a lot of u substitutions. So I know, like, I like the first integral should have been pretty easy. Like those should have been. Seems like most people. Helen, you did pretty well on them, but I think Juan, you just kept messing up. Yeah. Making major u substitution mistakes or something. Which pretty much every problem you had to make sure you did that right, and you just kept doing it wrong, and that really screwed you. Yeah. But anyway, do you get what you did wrong?
Yeah, I understand it now.
Okay.
I just overthought everything.
It seems like it. Your u substituting was off, and then everything got messed up. So, okay, there you go. So does everything make sense?
Yeah.
So I made a retake. You know, similar, but of course everything's different. So when do you want to do that? Do it tomorrow. You only have to retake the ones you missed. Yeah, for you. Be a lot of work. Yeah. Anyway, whenever you guys want to. Obviously, Buster can't do it yet, but he'll have to do it when he gets back. Okay, let's move on.
We do it Monday. We're gonna be here Monday now.
You will be here Monday for 42 minutes.
Oh, goodness.
That's the problem. The 42. I mean, yeah, now you're only here for 55 minutes. You know, it's better. You can. I mean, well, I guess, yeah, Callan, you only missed a couple, so you could easily do it during a class period. And if I wanted it, I don't know, it might take a while. Oh, boy. Well, we'll figure it out.
And like the thing is, well, that's not that bad. Like number 6, we all missed letter C, so we all got to do almost.
That's the
entire
problem.
6.
You do have to do the whole thing. Unfortunately, you do, and you can't get the top ones wrong, and you're totally screwed. But they're not that hard. Obviously, you know how to do it, but you're right. Everybody has to do that one again, and it's not that hard. Those are, you don't have to do B.
B to do C?
You don't need B,
No, it's A.
just A. And that's not hard. You just integrate it. Right? It take 10 seconds. That's not so bad. And I think what I'm going to do is, again, I do not think that these test scores are representative of what you guys are capable of. So we're going to just pretend the first test didn't happen. And then we'll just take the second test for your score. Which, again, for Cascade grades is what I do anyway. But for UW grades, they don't do retakes. But we'll just pretend that was a practice test. Because I think you guys can, yeah, it's not representative of what you guys should do. So do well on the retake. We'll pretend this did not happen. And it was good practice test. Okay, so how about the homework? Now, Juan, you're almost done.
I already finished it.
Oh, you did?
Yeah.
Oh, I didn't look. So when did you finish it? I looked earlier this morning. You're at 80%.
Finished it like 2 minutes before I finished in Avid.
Okay, so you had Avid, so you had time to do some other stuff. Okay.
I only have like 4 problems left.
Okay, cool. So it's, and again, they give you a tutorial thing, so it kind of makes sense. So, all right, well, Buster, hey, Buster, has more than that. But if you guys can figure it out, then I imagine he could figure it out if he takes the time off of skiing. So then we should move on then.
Yeah, the problems weren't really hard. It's just the last 2 with the diagrams, those were harder. Like with the piston
Uh-huh.
and the.
Oh, right, they get kind of weird.
Yeah, and
Like the
sucking
blood.
water in a container.
Oh, I'm looking at part B, sorry. So yeah, 4A. Yeah, once you get the idea, I don't think it's too bad. Okay, let's look at the next assignment then. So what? Oh, okay. The next one is actually kind of easier because there's just a nice formula. So let me think. Let's look at the book to tell us how to do it. Okay, so this finding the average, it's kind of cool, finding the average value of a function. So, did I already turn this on yet? I turn this on. Is this on? Hello? 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 There it goes. I think the volume's better for recording if I have this thing on. We're supposed to get these nice microphones. So like, because the people that are online, we're going to be doing the same thing. So we have better microphones that can pick it up stuff. This, if I have that on, I think it works better. But hopefully Buster can hear us. Questions. Okay, so the average value of a function. So let's say you have some crazy function, right? What's the average of that over a certain interval? So we want to know what the average of this blue line is over that interval, right? So how do you find the average? You take it at a whole bunch of places. Like we take it right here, and we take it here, we take it here, we take it here, and take it here. Right? We take a whole bunch of samples, and then we average them. So here it's negative, and here it's positive, and so and so they're saying looks like the average looks like a little bit below 5 or something, right? But we want to find if I do this dot thing and average it, well, the more dots, the better, right? The more dots I take, the better. If you want to average the height of the ocean, what's the average? What's sea level? What's the average height of the ocean? You don't want to just take it twice a day. You got to take it an infinite number of times. Gives you the best average. Of course, that's what calculus does. We take dots every whatever part, every delta x apart, and then as delta x goes to 0, we have the perfect average. right? So basically it's the function, the height of the function. Yeah, so that's what they show. So we take the function. Okay, so the average is the number of points, all the points divided by however many we take, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I take that 12 times. So it's the function at each point I take divided by 12, the number I have. That's the average, right? Divide by how many you have. So then, this is my x of I. So of course, if we put that at n, so it's the I equals 1 to n, the function at each I value divided by, oh, and then just divided by n. That's really all it is. So we just take a lot of points. I can put the 1 over n out there. Function at each I. So we take the function divided by how many are. And then, of course, as n goes to infinity, then we, wait. Forgot something here. Let's see, the average value of the function. Oh, no, I didn't. So, and then, f represents Richard. Since delta x, the width is b minus a over n, we can write, okay, yeah, so this n here, so delta x, the width of our interval, our delta x there, is the beginning a to b, so it's b minus a divided by the number of points. We do 12 points, the width is, the width is b minus a over n. So we want to get rid of the n. So n is equal to b minus a divided by delta x. So we can replace that n with b minus a over delta x. And that's what they did here. And then so the delta x goes to the top. So this becomes some, okay, I'm just going to turn off this background because we don't need it. We don't need the book. So this 1 over n becomes 1 over b minus a divided by delta x, sum of f of x of I from I equals 1 to n. Which is, put the dx in the top. So 1 over b minus a sum from I equals 1 to n of f of x sub I times, I'll put the delta x in there. And now you can see how this works. We let n go to infinity. As n goes to infinity, as we take an infinite number of points, delta x becomes dx because it's infinitely thin. And so the average value, how do they represent average value? Okay, so they just put the a. So f, a, b, e, f average. The average value of that function is the integral from a to b of f of x dx, fx dx, and I forgot, we have the 1 over b minus a. So 1 over the range. So you divide by the range, and you just integrate. How easy is that? So it's real easy. It's not like the volumes and the work done where you got to figure out the formula, right? What are you integrating? All you do is integrate the function from a to b, from wherever to whatever, to get the average value. It's basically the area under the curve, right? The average of the area under the curve kind of thing, divided by the range. I don't know. So let's see what. So y is, yeah, that's just the formula. So how can they make this hard, right? I mean, my gosh, it's too easy. How did they got to make it hard on you? So how do they make it hard? They'll figure out a way. So let's look at the problems here. So it's really just practice integrating. These are just practice integrating. So it's okay. Let's give you some use substitutions and what have you to practice integrating. So, but it's real easy. So what is the average value of that? You just integrate that from negative pi to pi. Divide by the range, which is 2 pi, right? The range is negative pi to pi. So b minus a, pi minus negative pi is 2 pi, so that's 1 over 2 pi. So the integral from negative pi to pi of 1 over 2 pi of 7 sine of 8x dx. Now, it is okay to cheat. It's okay to use symmetry right away. I know what this answer is, and you should too. What's the answer? Think about what a sine wave looks like. If we, sine wave looks, it's the same on the negative side, but it's negative. So whatever it is here, it's the exact opposite here. So if we integrate from the same thing to the same thing, one side is going to be the exact opposite of the answer we get on the other side. It just cancels out. So in other words, if you have an odd function like sine, it's an odd function, which means it's negative. Whatever it is on this side, it's exactly the same, but it's negative. From the same number to the same number of an odd function, it's 0. So right away, so, oh, sine's odd, 0. Now cosine, that wouldn't work, because cosine looks like this. So it's the same on both sides, but we could cheat on cosine. We could say it's 2 times 0 to pi, because it's a lot easier to have a 0 in it, plug in zeros. So cosine, if it's an even function, and if it's the same like that, we can just say, you know what, that's the same as 2 from 0, because it's going to be the exact same on either side. So to look for things like that makes it a lot easier. So the first one's obviously 0. Anyway, but this is just integrating practice. Like here we have to integrate secant squared, but you know how to do that. And I think they want exact answers, so you got a good trigonometry practice. Yeah, so I think these are, this section, like I said, you can't really make them too hard. Let's see if they manage to, because it's just integrating. This should be a pretty short section, because what can you do? Oh yeah, they figure out a way to do it. Find the average value, find C such that F average equals F at C. Okay, so here they're saying, where is the function equal to the average value? So find a number so that the average value is the X value of it, that it is the average. So where is it the average? So I guess there's 2 of them. There's 2 places where it actually is the average. Does that make sense? So that's a way to make it harder. So if you have some function, something that goes like this, if the average is, right through here, then there's a couple places where the functions can be equal to the average, and that's what that's what they have you find. Where is the function equal to the average? But that's not hard. You just set the function equal to the average and solve for x. So they try to make it hard, but what can you do? Same thing with like number 5, find numbers b such that the average of that on 0b is equal to 6. Okay, so you got to find the limit to make the average 6. So you integrate from 0 to b, and then you solve for b. Yeah. Okay, so those are pretty easy. Average value is a pretty easy thing. It's just a nice formula. You don't have to draw pictures and solve for volumes and work down and on and stuff. So should be pretty good. Okay, well, yeah, this one's probably one of the easier web assignments. Should go pretty fast. I will see you guys tomorrow. again, I have the tests ready, midterms, retakes, so whenever, you know, if you can try to figure out about how long you think it'll take. So whenever you want to, let me know, we can do it. If you give, well, if we're gonna do it during class, we should do it at the same time. So you know, which in probably be best during class. So Juan, can you do the same thing, like miss part of first maybe or something?
Yeah.
If you're worried about taking long, and I think, Cal, you don't have as much to make up, so you could probably easily do it in class. Should we just do it tomorrow? We have longer class tomorrow or next week. 42 minutes again. If you miss first, 42 minutes is. You guys will be in the morning. Nothing that matters, but we should do it at the same time. So.
Well, we could probably.
So when is it easiest for you to think to miss some time at
We
first?
could probably do it on Mondays. There's still gonna be 80 minutes total.
If you do part at first, which should be plenty for you.
Yeah, I should have enough time.
If you know how to do them, I mean, it goes really fast. Like you're just struggling with stuff, but once you know how to do the things, hopefully. That's okay. So Monday, so, and if Juan, you want to come in earlier on Monday, just it's my prep, so it's easy.
Okay. Yeah, I could probably come in earlier Monday.
And Cal, I think you should be able to finish it during class on Monday. So, okay, we will do it on Monday then. Okay, cool. Lester never showed up. We watched the video. See if he's there. He'll hear to say something. Stop recording.